All right, so in this video, what I wanted to accomplish was to show you how the analysis of variance technique works. Because I've said sort of tongue-in-cheek and sort of seriously, how the heck can you use variances to understand something about a group of means? We saw in the previous video that what ANOVA does is it works on a particular kind of a fairly common experiment where you take a number of groups, provide them different treatments, and look at their responses. And then you ask the question, are these responses different or are they same? That is if I change the treatment, do I change the response? And ANOVA answers that question. So let me do it like this. I've got a couple of graphics that I want to put up. Here's the fundamental graphic. It's got three groups, alpha, beta, and gamma to have a name, and along the vertical axis it's got some sort of measured response. And you can see there's data for each one of the groups. You can see the spread in the data. You can see the averages in the data. The very first group's got most of the spread, or has got more spread than the other groups. The second group has a higher average and not so much spread, and the third group is got an intermediate size spread and maybe the lowest mean. And what you're asking is, yeah, I see that those three means are all different, but this is statistic. You have to ask not are they different, but are they significantly different, right? Are they different enough that you'd say, well, I can really distinguish some difference in response due to treatment alpha versus treatment beta versus treatment gamma. So let's get rid of that, put up two more, and let me talk about now for a second what are the variances that we're going to look at. First of all, let's just back up a little bit and remember that in ANOVA, what we're going to do is have a null hypothesis, and that null hypothesis is going to always be, no difference in the means. That's always going to be the case, and the alternative hypothesis is going to say there's at least one mean that is different. And I told you last time, I hope that's enough for you because ANOVA does not identify which of the one means. And there could be two means, it could be three means, there could be any number of means that are different, but ANOVA won't give you any idea to what it even means to be different. It'll just distinguish whether they're all the same or they're not all the same. Okay, so on the left here, what I'm describing here is what's called the variance within. Right? The variance within is associated with sort of the intrinsic variances within each group. And that's indicated in this case by the length or width, whatever it is, of these box plots, right? Again, most of the three groups, the alpha group has the longer box plot, the more variance within. Certainly more than the alpha beta group does and more than the gamma group does as well too. So there's the measurement of it in the box plot, but you could actually calculate for each one of those groups, and you could do it with your calculator. You could calculate a variance for each one of the groups. So this is I'm going to call it the intrinsic statistical fluctuations. Okay, and in the case that all of the different groups, all of these three groups, each have the same number of members, the same size, then this overall number, this S within, is what's called S pooled, S squared pooled, and it's just equal to the first variance plus the second variance plus all the way out, if you've got k groups, to the kth variance divided by k. It's the average of all the variance. So you would find the variance here, variance there, average them all, call that S-squared pool, and that is in fact the variance within, the first of the two variances that we're looking at. So if we go over to the second group now, the second variance is just associated with the means. There's a mean value here, mean value there, mean value there. Three different values. If you were to put those, load those into one variable stats, you would calculate a variance, and it's a so-called variance between. And this is differences due to the treatments. Yep. And again, in the case where n is all the same, then there's a simple calculation for that. The variance between is just equal to n times the variance of all these averages. Right? Take those three numbers, calculate the variance, multiply by n the number in each group. Okay? So once you have those two values, what you create is the test statistic. And that test statistic is called the F ratio, and it's equal to the variance between squared divided by the variance within squared. Now, I think you've seen in your book that if it's the case that n is not the same, if they're all different, there's a different set of formulas and they're a little bit more involved than these simple formulas. Not so much to worry, because largely most of the problems you're going to see you're going to handle with your calculator by just entering data and letting the calculator do the calculation. I'm actually going to have you do some of these calculations just so I can help you ingrain that this test statistic is S sub b squared all over S sub w squared and so on and so forth. But I'm not going to have you do many of those. I'm not going to have you do any associated with the formula that you're going to find in your text. So once we have that test statistic, what are we going to do? We're going to run a hypothesis test is what we're going to do. We're going to calculate the p-value associated with this, compare that to alpha, and we're going to either reject or fail to reject the null hypothesis. Okay, so let me fade away now, erase the board, and come back and really do what I wanted to do, and that is explain exactly how this works. All right?